Example, if an object is inside the lift or elevator. Now, this is also having three scenarios. Number one, if the lift is at rest or moves with constant speed upward or downward. It can be any direction. These all scenarios having a same result. If the lift is at rest or move with constant speed upward or downward. So example, this is a lift which is attached. A cord is there. This is a cord which is attached. And there's a person inside the lift. So what happened? Because this lift is either at rest or it move with a constant speed. So if something is at rest or move with a constant speed, so there should the resultant force will be 0. Means there is no resultant force. So if there is no resultant force on the lift, there should be no resultant force on the person. So what happened? The weight of the person is acting down, and the normal contact force is acting up, R. If I say that weight of the person is say 600 Newton. So what is the normal contact force? The normal contact force will also be 600 Newton. So in that case, when I will say R is equals to W, or the weight and normal contact force will be same. When object is the lift is either at rest or it move with a constant speed, but it can be a constant speed upward or downward. It does not make difference to this scenario. So in that case, like example, if I say weight of the person, if actual weight of a person is 600 Newton, so what will be the weight he will feel inside the lift? Inside the lift also, he will feel 600 Newton, his weight, the normal. But if this lift was accelerating, if this lift was accelerating upward or decelerating downward. If there is acceleration up or deceleration down, example, this is a lift. A cord is there which is attached to the lift, and there's a person inside the lift. So a person is there inside the lift, and this lift is accelerating up. Accelerating up or decelerating down having a same meaning. So if it is accelerating up or decelerating down, which force is greater? Upward force or downward force? If this lift is accelerating up, which force is greater? The upward force is greater because it is accelerating up. So if it is or decelerating down, both cases it means the upward force is more than the downward force. So if we draw a free body force diagram, the weight is acting down and the normal contact force is acting up. So that it can accelerate up. So if I write in terms of equations, like representing this statement in terms of equation. So as we know, the Newton's second law, F is equals to ma. Basically, what is this F? This F is a resultant force. So what is the resultant force according to the person inside the lift? Acceleration of a person will be same as acceleration of the lift. So R minus W is equals to ma. Or you can see R is equals to W plus ma, or ma plus W. It's the same thing. So what you will find the normal contact force increases. If the normal contact force increases, what it appear? It appear that this object become heavy. So whenever the lift is accelerating up or decelerating down, what it appear? We will not have the same weight. Our weight will appear to be higher than the actual value. Like example, if our normal weight, like if I consider with the previous example, the weight was 600 Newton. But now what happened? Because it is weight plus ma, so weight will appear more than 600. Example, it appear as a 650 Newton. The new weight, because the normal contact force is a balance, it is balancing with a downward force. So actually the downward force appear to be the normal contact force is causing, like there's an acceleration upward. So as the normal contact force increases, it means the apparent weight, this is not the actual weight, it is called apparent weight. It appeared that the weight of the object increases. Is it clear, this scenario? When the lift or object is accelerating up or decelerating down, it appears that the object become heavy. And the third scenario, if, because the previous was, it was accelerating up and decelerating down, the third condition is if it is accelerating down or decelerating up. So if lift is accelerating down or decelerating up, so this is a lift attached with a cord, and a person is there inside the lift. So in this case, which force will be greater, as it is accelerating down or decelerating up? So which force is greater? The downward force will be greater because it is accelerating down. So it means the downward force is greater than the upward force. So as the downward force is greater than the upward force, so the weight, the downward force, basically the weight is the downward force and the upward force is the normal contact force, or R. So when we write this statement, because according to Newton's second law, that whenever there's a resultant force, that's equal to ma. So resultant force is equals to ma. Resultant force, that weight minus R is equals to ma. And W minus R. So if I need R, if I solve, R move other side and ma move this side. So R is equals to W minus ma, or R is equals to W minus ma is equals to R, or R is equals to W minus ma. So what it appeared? It appeared that the normal contact force decreases. If the normal contact force decreases, that the apparent weight, not the actual weight, actual weight is there, but apparent weight, the weight which appear in this condition, the apparent weight will decrease or object will appear to be lighter. So if normally if it was 600 Newton, now it will come out less than 600 Newton, example 530 Newton. The value will change according to the acceleration. I'm just using the numbers to relate with the first part. So when object, so this is what happened when the lift is accelerating down or it is decelerating up. So if you are standing on a balance, you will find that your weight will decrease. But if lift is accelerating up or decelerating down and you are standing on the balance, so it appears that your weight is increased. And when the lift is either at rest or it moves with a constant speed, then if you are standing on the balance, your weight will appear as same as you are on the ground at a stationary object. So these are the three scenarios for an object which is inside the lift. Is it clear, this case? Any doubt in this part? Now, forces in a tension in a rope. Tension in a rope, basically when force is applied by using a cord or a wire. So when force is applied by using a wire, string or a cord, what we call that force as a tension. And it is always the tension, the direction of this force is always to pull the object. So which direction you're pulling the object, that will always be a direction in which the tension is acting. Then it can have different scenarios, like example, you have two masses or two trolleys are there, or two cars, or a car, like a tow truck is there. Example, this one is 20 kg and this one is 800 kg. Okay. And this whole system is accelerating, and its acceleration example is 2 meter per second square, and it is attached by a string or a wire. So between them, there's a string or the wire is there. The two objects are attached by a string or the wire. Now, if we need, like example, if we need a tension, and the friction force, it can be a friction force can also be given, like it depends on the question. Sometimes the frictional force is given, sometimes the friction force is not given. If it's not given, it means you are neglecting a friction. So different scenarios according, if for example the first case, if we are neglecting the friction and the question is find tension in the rope. So basically what happened, the acceleration, the total acceleration is 2. So what is the acceleration of 200 kg? That's also 2. Because if they have different acceleration, they cannot maintain the constant distance. So both will have the same acceleration. This is called a multi-body system. Like when many bodies join together and form one body, we call that as a multi-body. So acceleration of 200 kg and acceleration of 800 kg is same as acceleration of each. So if I need the tension in the rope, and also I need the driving force. Here friction is not given, so friction is neglected. So if I need a driving force, so I will like the force which is driving this whole system, like this is say a railway carriage is there, and if it's a railway carriage, then all should have the same masses, all compartments. But the same way you will use. So if I need a driving force, basically what I will consider both of them as one object, like multi-body system. So this whole system is having acceleration of 2, and I need a force which is driving. There is no force which is opposing, like friction is not given. It can be given. If friction was given in the question, then what will be the statement? It will be driving minus friction is equals to ma. But if friction is not given, then it is actually driving minus, not minus, because friction is negligible. So driving force is equals to ma, because the resultant force is always equals to ma. So we need a driving force. What mass I will take? Because the total mass of this whole body is 1000. 200 for one and 800 for the second one. So total mass is 1000. What about acceleration? That's equal to 2. So the total driving force is equals to 2000 Newton. Is it clear, the first part? Then if I need a tension, so what is the direction of the tension? I told you direction of the tension is always to pull the object. So for 800, if I consider 800, the tension is towards right hand side. But if I consider 200, then the tension is towards left hand side. So if I need tension, both values of a tension will be same, but relative direction of a tension will be different. It is according to the mass which we consider. So if I consider 800 kilogram, so we have the formula that resultant force is equals to ma. So if I consider 800 kg, so for 800 kg, T is there is no friction, and mass is there, which is 800, multiplied by acceleration. Acceleration of the whole system is same as acceleration of this, so it will be 2. So it will be 800 multiplied by 2, which is equals to 1600 Newton. Is it clear? Because now what I did, I consider individual object, like I consider only this object individual. But I can also solve this question by using a 200 kilogram object. How when I consider 200 kilogram object, so now what are the forces? Because there's a driving force, basically that's the part which is driving. So there's a driving force, that driving force is 2000, and the tension is there according to this 200 Newton. Tension is opposing, like pulling it, opposing its motion. So when we apply a Newton second law, resulting, because it is accelerating, so resultant force is equals to ma. So what will be the resultant force? So it will be, yeah, basically the result, if we don't know the tension, I can find the tension also by this formula. So it will be D minus T is equals to ma. D is 2000 driving force minus T is equals to mass, which is 200, and this A is 2. So if I need T, 2000 minus this 200 into 2, 400, it will move other side, minus 400. And again, you will find what I will get T. So I'll get 600 Newton. And I told you, I will get the same answer, but the only difference is the direction, because the direction of the tension for 200 kilogram is backward, and for direction of the tension for 800 kilogram is forward. Is it clear? This concept, tension in the rope when objects are attached and moving on the horizontal surface. Any doubt in this part? No, driving force is not always towards right. It depends on the question. Like as I mentioned, that object is accelerating towards right. So the direction in which the object is accelerating, that is a direction. Like basically the direction of the motion is representing a driving force. So it will be given in the question, like which direction the object is moving. Same thing, you can have objects attached by a string on a vertical plane. So two objects are there, 8 kilogram and 2 kilogram. And so this is 8 kg. This one is 2 kg. If I say this is M1, this one will be M2. So when we draw the free body force diagram, the direction of the tension first. So if I say this is T1, so that's acting up. And for T2, it is also acting up, because I told you the direction of the tension with respect to object is to pull the object. Then what are the forces acting? If I consider the whole system is stationary, whole system is at rest. So rest means there is no resultant force. When I consider 8 kilogram object, so when I consider 8 kilogram object, what are the forces acting? The tension T1 is acting up, and the weight of 8 kilogram object is acting down, and weight of 2 kilogram object is also acting down. So when I consider so what are the forces? Because the upward force equal to downward force. So what are the downward force? The weight of 8 kg and the weight of 2 kg, both are acting down. So both are contributing to the downward force. So this is W1, this will be W2. So I will say T1 is equals to, because it is at rest, so there is no resultant force. So the upward force equal to downward force, that will be equal to W1 plus W2. But when I consider only 2 kilogram, so when we consider 2 kg object, in that case, T2 is acting up and W2 is acting down. So T2 is equals to W2. So we can solve this and we can find T2 and T1. How I can find first T2 and how I can find T1? So T1 is equals to W is equals to mg. So mass is 8 multiplied by acceleration due to gravity 9.8 plus weight the second is mass is 2 multiplied by 9.8. What's the final answer for T1? 8 into 9.8 plus 2 into 9.8. First multiply them and then add. What's the final answer for T1? $98. So T1 is equals to 98 Newton. And what about T2? T2 is mass because it's equal to W2, so it will be 2 multiplied by 9.8, which is equals to 19.6. So T2 is equals to 19.6 Newton. Is it clear, this part? Then object can be attached by a pulley. So if objects are attached by the pulley, the object can be stationary or object can be accelerating. If it is stationary, in that case, like example, if this is a pulley, and a string or the wire is passing over this pulley, two objects are there. It can be like stationary. If it is stationary, like if this is M1 and this one is M2, so with direction T1 will act, T1 will act upward, T2 will also act upward because direction of the tension is to pull the object. The weight of W1, weight of the first object will act downward, and weight of the second object is also acting downward. So if I say, if this object is stationary, if it is at rest, like it is not accelerating, so in that case, I can say the T1 is equals to W1 and I can say T2 is equals to W2. But if it was accelerating up, like not the whole system, if M1 is accelerating up, and M2 is accelerating down, and because it is attached by a string, so both should have the same accelerations, like the downward acceleration will be same as the upward acceleration. The direction of acceleration is different. M1 is going up where M2 is going down, but both have the same accelerations. So when I write the equation for this scenario, if two objects are accelerating, so for when I write the equation for the first one, for T1 or for M1, so for M1, T1 is acting up, so I can say T1 minus, because whenever there is an acceleration, the resultant force is equals to ma. So T1 should be more and W1 should be less, so T1 minus W1 is equals to ma. And for M2, W2 minus T2 is equals to ma. But this will be M1a and this will be M2a. But both will have the same acceleration. That's why I use the same symbol. Is it clear, this equation? So according to the scenario, you have to make the equation. It can be M2 can accelerate up or M1 can accelerate down. And just substitute the values. I did not use the values here. I'm just using a variable to show how you will form an equation. Is it clear? So any doubt related to the class today? Today we discuss about the forces, the moment, momentum, and different scenarios in which you draw the free body force diagram and use equations to solve questions related to resultant force, acceleration, driving force when objects attach with a string or when object is on the inclined surface. Any question or a doubt related to the class? So I'll end the session and share the recording with you. Don't forget to submit the weekly homework tomorrow for discussion and mention your doubts when you submit the homework as well as during the class.